In this section, we will consider how to specify which flows we consider to be admissible. A traditional approach is to have a so-called security lattice, where the ordering indicates how information is allowed to flow. We shall take the point of view that information may always flow from lower to higher. Formally, a partially ordered set has an ordering that is reflexive and transitive and antisymmetric. We may draw the ordering as a so-called hazard diagram. In this example, there is a line between public and private, and public is lower than private. So therefore, public information may flow into private information, but not the other way around. To be a lattice, the ordering must satisfy some conditions. Speaking informally, every two elements must have a maximum and every two elements must have a minimum. Speaking formally, every two elements must have a join that is larger than either but no larger than necessary. And similarly, every two elements must have a meet that is smaller than either but no smaller than necessary. The online system supports partial orderings even when they are not lattices. Let us consider some examples of security lattices. We already saw one for confidentiality where public is less than private. A classical example is where we have four levels ranging from unclassified to top secret. Sometimes we go beyond the linear ordering, as when classifying data as to whether they contain financial information and/or medical information. Turning to integrity, a simple example shows that trusted data may end up in dubious data, but not the other way around. Or we may classify the trustworthiness of data from the known fact to alternative fact. Or we may classify the execution of code as to whether we need to trust the host or the client or both. On top of the security lattice, we need to assign security levels to all the variables and arrays. Formally, this is taken care of by a security classification, which is a mapping from variables and arrays into the elements of the security lattice. A flow is permitted by the policy whenever the variable x flowing into y has a security classification that is less than or equal to that of y. Consider the example where public is below private. Let x be private but y and z be public. Then the flows permitted by the policy are the ones expressed here. The column on the right says that public data can flow between themselves. The column in the middle says that data can always flow into itself. And the column on the left says that public data may flow into private data. Let us consider a variation of our example from earlier. The array A now belongs to Alice and the array B to Bob, and they want to keep their arrays private to themselves. For this, it may be natural to use the following security lattice where the shared levels should be avoided. Use the online tool to specify a security classification for realizing Alice and Bob's intentions. Use the online tool to check that you got it right. Having done this, you should read the section in the book doing the try-it outs on the way.